Well, let's go ahead and start then. Thank you for your patience. I truly appreciate your attendance. And I want to thank the leadership committee from El Paso ASQ to allow me to give this conference to the whole group, okay? So truly appreciate it. Today, I'm gonna try to explain what is the Hatelin T-square control chart, okay? So many people know it as a multivariate SPC, okay? And looks at the beginning, there is something sophisticated, but once you understand the concept, really is not, is not complicated to understand exactly what it is. Obviously, if we have several measurements or variables, it's gonna be hard to make, manual calculations, because those are matrix. But we were talking about computers these days, and now with computers, this is a lot simple. So something that I want to say is that these days, what is needed in the manufacturing environment are real-time sustainable quality systems, real-time, okay? So something that is ongoing, providing, inspecting the product and providing the product disposition at the same time. And we want to move from correction to prevention and now to prediction with quality 4.0. Something that I want to show you quickly is the strategic alignment. This is something supporting TQM. Remember TQM in the 80s, total quality management?
Yes.
Supported by the quality gurus like Deming, Duran, Crosby, Fagenbaum, Ichikawa, all those guys. So those days, in the 90s, you could see beautiful structures, really, absolutely amazing. But what happened with those structures and what happened with TQM? The problem was sustainability. So it was not easy to have sustainability because not easy to maintain. So it was a total employee involvement and was not easy to keep it. Okay, I still remember in my days in Baxter, when I was in charge to promote the quality leadership process, was another TQM. And I used to go to the facilities in Mexico, Chihuahua, Delicias, Cuauhtemoc, and Juarez, and we encouraged to do the QLP. It was, at the beginning, like a big balloon, so everybody can see the QLP, a lot of enthusiasm. We used to share, a lot of gifts, and the people was totally enthusiastic. I used to come back to the facility 6 months later, and I asked to the people, well, where's my balloon? Well, nobody is pushing the ball anymore because the process was not easy to sustain, not sustainable. So I used to give cakes and food and everything to the people so we can pump out the balloon again so I can see again, oh, here's my balloon. And I did it several times until I got tired. Says, no way, it's not possible to maintain this system. It's not easy. So that's why when I was in Medtronic, I developed this strategic alignment, which is something practical. The objective is exactly the same, to achieve the quality excellence and achieve a substantial overall cost reduction, and really, works. I'm talking about this because the T-square that I'm talking about today is part of this strategic alignment, and you can see it over here in the number 3, the core inspection tools is right on the bottom. The T-square is one of the systems that is being used to support the manufacturing facilities. Okay, they gave us many benefits. So I'm gonna try to explain and give you a little bit more information about the how this assembled with the strategic alignment. But one thing we can say, that it's not possible to achieve the quality excellence and the overall cost reduction with just one thing. That's why we have, 11 things right here supporting the path for excellence in manufacturing. Okay, just keep it like that. Okay, we're gonna move in a minute to the T-square concept, but I don't know if you agree with me, but a facility in TJ is about, is close to 6,000 people in that facility. That facility last year won the quality award in 76 plants in Medtronic using these systems. Okay, so that's why I'm a true believer that this strategic alignment works. Okay, I don't have the time to explain more details, but that's what it is, all these areas. Anyways, let's go ahead and introduce the T-square. And the history is that in 1947, Harold Hattelin introduced statistics which allow multivariate observations to be plotted in a single chart. Amazing, right? And this statistic is now called Hattelin T-square statistics. All right? You remember the SPC? Remember when we have the fever in the 80s? So everybody was involved with the SPC. But let's go back in history when the SPC was developed. The SPC control chart were developed in 1920 by Truhart. And you can imagine, 6 decades later, those tools become popular. So now we are seeing the T-square developed in 1947. And these days is becoming, a little popular because of the computers. Obviously, if we compare the level of complication calculating the SPC traditional X-bar, the X-bar range charts and X-bar standard deviation chart in comparison to the T-square, it's another level of difficulty. Okay, so that's why the T-square didn't succeed in the past. Lack of software, lack of computers to help controlling the processes with the T-square statistics. This is an example of what it is, the Hattelin chart. So looks like this. Only one upper control limit for the chart. And you have all the inspections that are being performed during the day or time, whatever. And you can see here, we have an out of control. So that's why everybody is alerted what's going on, okay? So the Hattelin T-shirt, the beauty is that you can have the control of several variables. I can say up to 9, okay? You can imagine you have a product or a process where you have 9 variables. How many SPC charts you should have? 18, right? The X-bar range. So you have 18 charts. With T-square, only 1. Okay? And you can say, really? Yeah, it is possible to declare the process out of control or accept it anytime. So let's see what is the definition of the Hattelin T-square. Here's the concept. Hattelin T-square is considered to be the next generation of SPC. And it's a technique for monitoring the overall quality of several characteristics. We'll come back in a minute, why 9 only. It is a powerful statistical process monitoring technique applicable in modern manufacturing automated processes in which product characteristics have some level of dependence. Can you remember the SPC concept? We didn't have any restriction like that, right? The level of dependence was not in the game. So the level of dependence according to Schuchart is 0 when it's not true. In many processes, we have some level of dependence, so the covariance is not 0. And the Hartley t-square using real-time process data from a set of measurable characteristics, and with just one control chart will be sufficient to accept or declare the process out of control and subsequently take immediate action. Okay, that's the beauty. Okay, now let's see the benefits then. Because once you see the benefits, then maybe you're going to be enrolled using the t-square in the future. The Hartley t-square is a real-time process monitoring. Why is it real-time? Because it's inspecting your product, you know, since the beginning to the end, and will identify product functionality issues. How about that? Product functionality issues. And I'm going to give you an example about this. I read an article where a car manufacturer used to have customer complaints in their cars because the transmission was not working well in the field. So they hired a statistician, and the statistician conducted a deep investigation and found that the shafts using those transmissions were made in the biggest diameter, close to the upper control limit, and the bushings were made in the lower control limit, you know, one in the upper and the other one in the lower side. So what happened with these transmissions running in use? With a little heat, the transmission get tight, okay, because the shafts and the bushings were, you know, in the opposite dimension. But what happened? They used to have SPC control charts for both, for the shafts and for the bushings. But nothing was identified as an issue because both were in compliance with the specification. So that's why those shafts and bushings were not rejected in process. Because again, the SPC is not considering the covariance. I hope I explained the issue and with this example. Okay. Product functionality. I'm going to give you another example. At the beginning of this decade, I used to provide help to a facility in Juarez. It's a Ford facility manufacturing the racks with a little motor that are used to raise the windows in the cars. Okay, whenever you push, you know, up and down, that's the motor that is doing the job. So they were manufacturing the racks with the motor and sent it to the assembly facility. And guess what? The plant manager was almost crazy because he was getting a lot of rejected parts back, returned to the facility. So what happened? The rack, when the operator was to assemble it into the door, was not possible because those pins were not assembled right. And they prefer to put the part in the scrap instead of stopping the line, right? So that's what happened in that facility. You know how many measurements they had back then? 9 variables, 9. When I went to the facility, they used to have 18 charts in front of the manufacturing lines. And I asked the plant manager, which one is the one? Okay, 18 charts to control the process. Can you believe it? It's a nightmare. So back then I proposed him, why don't you use the t-square? With t-square, you're gonna have only just one chart. And it's gonna tell you when your process is out of control in order to avoid the product functionality. You use it. Since then, the problem disappeared. Okay, so they were absolutely happy using the t-square. Years later, I got a call from this plant manager, not even remember him, you know, and he called me late and I said, who are you? And he told me, you don't remember me. You know, I'm the plant manager from this facility. Remember that you implemented the T-square? Yeah. Well, I'm calling you because people from Detroit went to my facility and they evaluated the system and they like it and they want to take it to Detroit. And I'm asking you, is that a problem, or you can allow these guys to use it? And I told him, if it's useful, use it. For me, it's not a problem. Okay, that's a success story. Then let me tell you another one. When I was working for Medtronic, we used to have many complaints, and some of those were recalls, product recalls in catheters. So it's a medical device catheter that used to go, I don't want to say it, but goes right there, you know, all the way through. And they drain, you know, whatever they want, and they inject fluids, you know, to clean the whole thing. So that catheter used to have a small balloon, like an inch in diameter. So whenever they introduced the catheter, they inflated the balloon, so you can keep it stay, you know, until they finish the process. But what happened in some cases, the balloon blown, pop out. So the catheter pulled out, right? Instantly. And they were absolutely mad because they need to redo it again. I used to be in conferences with doctors and nurses. They were absolutely mad with me. In some other situations, that balloon didn't burst, and they need to introduce a needle in order to burst the balloon and pull it out. So both cases were not good, okay? I introduced the T-square concept in order to say, well, the thickness of the plastic, the resistance, and whatever, you know, goes into a variable needs to play the game. Obviously, back then, I didn't want to develop another software like the one I did a decade ago. I decided to buy the Statistica software. Beautiful. Statistica can give you a good support to develop the T-square charts. It's only $2,000. For a company, it's nothing. So we use that software. We fix the problem. Never, ever again we have a problem back. Similar problem like that. Okay. So that's why I'm promoting this tool, even though, you know, it's a little difficult to understand at the beginning, but it's bringing, you know, very good benefits. The next bullet point is consider the dependence. You know, we talk about it, you know, the level of dependence between the product characteristics. Shuhar is not doing it. Yes. The last one, the last benefit is it will reduce the scrap, rework, product recalls, or complaints in the manufacturing efficiencies too. Okay. It's very useful, really, the T-square. That's why I put it into my core inspection tools as a support. And those are the equations, so you can see, you know, that it's not easy to do the calculations by hand, because whenever you see the equation right in the top, it's matrix. Okay, it's a matrix equation. So that's why it's not simple. You have, you know, the sample size and the mean and everything else, but everything is matrix. Not simple, right? Can you imagine if you have 3 measurements, you're gonna have a matrix 3 by 3. If you have 5 measurements, you're gonna have a matrix 5 by 5. So not simple. Now you have the limit 9. Can you imagine a matrix 9 by 9? Not simple, right? So take a look over here, these equations. You can see the upper control limit, and the upper control limit is based on the samples, in how many variables you have, you know, things like that. But what is driving the value is the F distribution. F. I know you have used the F distribution, you know, in the past somewhere, but that's the beauty of the F distribution. And we can decide about the risk. Usually is 1% in these cases. Okay, 1% is the significance level. So you can see right here, n sample size, number of samples, number of characteristics, and F indicates that the F distribution is used. So this is just an example that t-square by hand, no way, no way. That's why it's not popular. Not many people knows about how to do it automatically. Well, let me tell you something. I'm going to give you an example in a minute, and that example can be done using Minitab. Obviously, you know, it's not as automatic like Statistica whenever you have an auto control. But yeah, you can use t-square using Minitab. I'll show you how to do it. This is an example. Very simple, so you can understand the concept. A manufacturing process producing an adhesive with two variables, the pH and viscosity. Okay? That's a chemical process. And you have this data. You have 20 batches here, the data for pH and viscosity. So you can see right here, 20 data points for both pH and viscosity. And obviously, you can have your SPC traditional chart, the Chuhar chart. And if you can see, and if you see this chart, the pH is behaving very well, right? Not a problem. If you see viscosity, well, a little more dispersion, but still within the upper control limit and lower control limit, so it's fine. So what's your decision using SPC? Release the product, right? That's your decision. Release the product because I don't see any problems using SPC. But the thing is that SPC, as we said, they are not considering the level of dependence. Oh, let's use t-square. So if you go to Minitab, you're going to find t-square in this location. Go to the stat, then control charts, then multivariate charts, and then you're going to find the t-square right here. That's the one you're going to use. Okay? Simple as that. It's absolutely simple. Oh, what happened when we do the calculation of these 20 measurements? Everything was looking beautiful with the SPC charts, but now we have another control in batch number 13. Is it really? Yeah, batch number 13, we got a problem, okay? And shouldn't be released because product functionality is affected right there. Well, then we say, okay, what's gonna be the methodology to use whenever we have an auto control and you are using Minitab? When we have an auto control, what we need to do is to decompose the data and run the t-square calculation again for both situations. I'm gonna give you a spreadsheet so you can understand exactly what to do. So you're gonna do it with two variables, with the pH and the viscosity, and you are going to see the difference between that new value with the original value. And whoever had the larger difference, that's gonna be the variable responsible for the auto control. Okay, so we run the t-square again, removing the data from the viscosity and removing the data from the pH. Okay, remember, it's the batch number 13. Now we don't have auto control. We'll remove it. So this is the whole story right here. You're going to understand exactly what happened. This is the original data right here, the 20 batches and the 20 data points for the pH and 20 data points for viscosity. So the batch that is in problems is the number 13. And the t-square value for that batch is 13.72. But the upper control limit is 12.57, 59. So it's out of control. Remember the chart right here? It's out of control. So we say, okay, now what to do? Well, we're gonna run the t-square again in Minitab, removing the 311 that is right here for viscosity. We run it and we obtain the t-square value 139. Okay, so we put it back, and then now the one that is to be removed is the pH value, the 8.2. Now it's not here. We did recalculation again for the t-square, and it was 4.49. Now what we need to do is to subtract this value to the original value. Okay, it's right here, 13.72 here minus the 139, and the difference is 12.33. And then we go with the next one. Now 13.72 subtracting the 4.49, and it was 9.23. And the rule says that the biggest difference, that's the variable that is responsible for the auto control. Okay, so that's it. So the difference for the pH is 9.23, and the difference for viscosity is 12.33. So based on the criteria, it appears that viscosity is the variable responsible for the auto control. And the decision is that you need to reject the VASH 13 because it's gonna cause functionality issues in the field. Okay. Well, as you can see, my example was very brief. This is exactly what it is, t-square. But if you want to use it in the manufacturing environment with rich companies, don't doubt to buy, software to do it. One option is going to be Statistica, $2,000, and the other one is Stat Graphics. Both have the t-square. Okay. So that's exactly what it is in concept with the t-square. I put this picture right here because all the manufacturing environment is nothing else but an orchestra in which we have many people, with different instruments. We have the director, but what is important here is obtain, harmony to listen the sound of success. That's the concept. We don't want to see that quality or production or engineering or maintenance are the kings, nobody's going to touch these guys. No. We want everybody to be in harmony, playing the same music. Additional information, references. My references are Journal of Quality Technology, right here with Curry and McGregor, multivariate SPC methods. And you identify right away that the Journal of Quality Technology is promoted by who? ASQ.
Claro.
Okay, yeah. Another one, Robert Mason, Journal of Quality Technology, another good reference. Montgomery book, Introduction to Statistical Quality Control, New York. That's a great reference, the Montgomery book. And the last one is from Technometrics. It's another one from ASQ.
Yes.
So as you can see, ASQ is supporting the best statistics in the world. Okay, I don't know if you have seen these journals, but the statistics this guy throw is high level, really.
Yep.
We need to dive very deeply in the concepts in order to understand what these guys really mean. Okay, but those were my supports. In order to make the software back then for Ford was not something simple for me. I had to go to many references and found exactly what to do. I told you, I'm gonna back to the 9 measurements as a limit, and you can ask me why only 9. Well, the thing is that if you consider 10, 11, 12 measurements into the t-square chart, since it's a test of hypothesis to declare the process out of control or not, guess what? The type 1 error in test of hypothesis degrade. Okay, And you're going to see, if you see Statistica, that they consider to use 10 variables. I don't. I disagree with these guys because I did the calculations. And whenever you use more than 9, the type 1 error degrades. So maybe Statistica made it in order to make it easy. Okay, consider 10. So it's not a big issue. I don't. So that's what it is, T-square. It's not a big deal. I hope I could explain the concept about T-square and the usefulness, because really it's very useful. Those success stories that I told you are real and can be implemented, I'm sure, in many situations in the industry. So we need to forget about the SPC charts because those are beautiful, but many inconvenience. Okay. How come the level of dependence is considered 0? No way. Okay. So that's why the fever of SPC, two-hard charts were everywhere in the 80s. But I don't see too much, SPC in the plants, okay? And if they do it, it's because they want to impress the visitors. But it's not gonna do too much for you in order to make good decisions. Okay. Well, that's all I have to share. I hope you like it. I hope I could explain the concept with you. But I'm open for questions.
Okay, well, I'm very intrigued by this. I mean, I haven't. I know you had mentioned it in the about this before, and one of the questions in my mind is identifying those particular parameters to be measuring, right? Because they have to make choices. So how do you are you just looking at like the existing data and then you run it through this and see like does anything show up as important, or do you I mean I guess I'm trying to understand, how do you know which are the right factors or parameters to be
That's an
incorporating?
excellent question, Kit. For example, let's go to extrusion. One simple extrusion that we can see is that they manufacture the hose, right? Outside diameter, inside diameter, and the thickness, right? Obviously, those 3 measurements are dependent, right?
Mm-hmm.
And T-square is going to be very useful to control the process and declare it, out of control whenever it really is.
Mm-hmm.
Okay, so if you have a SPC chart for the outside diameter, inside, and the thickness, well, it's going to be just an information, but it's not going to give you the right decision when declare the process out of control. But we have some other cases in molding, for example, in which you have more than 3 measurements.
Yeah.
Easy.
Well, I understand that. I guess I'm still getting to the question, like, because I've seen people collecting data without really a plan for it. Right. I mean, I've seen a lot of that, especially now because you can record so much stuff, right? There's sensors on a lot of new equipment. And so they even if it's not applicable because they have the data, maybe your customer demands you collect data, whatever. You're collecting data. And I like these T-squared tests. I'm just wondering, like, how do you do you use DOEs or do you do some kind of process monitoring to figure out which factors
Okay.
should we be monitoring?
Yeah. Well, that's an excellent question, Kid. Maybe something useful could be, to run a factorial analysis, DOE factorial, and you identify, the importance of all the measurements, right, in the Pareto, and try to implement the T-squared with the top ones, with the major ones. That's an option, right?
Yeah. Well, I'm just it gets back to I can see why people stick with the Shewhart control chart, because basically you get one data stream and you can feed it into an SPC chart super easy. You can automate that. I'm actually wondering about the statistical process control software that's out there, like WinSPC, if they have this kind of feature, because I mean, you would expect them to. It sounds like. I mean, I'm intrigued by the idea, and now it's just a question in my mind. Oh, okay, well, if because I've seen that ellipse before, in terms of like, oh, when you got multiple factors, or two factors at least, you've got that ellipse where, okay, you've got to be within that ellipse to be normal, and if you go outside of it, it's not normal, and with the two factors, and so as I said, it's just identifying what are the factors, right? Because some people just say, "Oh, well, you told me to run a study, and I put in my factors and left it at that," right? There was no uh, brain power applied. So that's where my question is coming from. I was like, "Well, how did you know which factors to control?"
Yeah. No, and it is a great question. That's why I propose, if you want to be more certain in the factors you're going to pick, to run the factorial DOE and identify the major ones, right? So there's no question about it. So you're going to see the major bars, that are taken care with the output.
Yeah, and I guess in that situation, if you ran the DOE, you would be saying, "Oh, look, I find that there's an interaction," because if you ran the DOE and found that all of the parameter effects are independent, then the regular Shewhart chart's fine.
Yeah, but we have a traditional joke, kid, in the industry, that says that the traditional SPC is like the manzanilla tea. Everybody likes it, but do nothing for you. It's a bad joke, right? But that's what people used to say. That's why, yeah, if I see one of those charts, the X bar range or X bar standard deviation, and the two measurements have some level of dependence. So what's going to be your final decision to accept or reject?
Yeah.
The beauty in T-square is that identify potential functionality issues, like the example with the car transmissions were not identified by the Shewhart charts. They were in compliance with the spec.
Yeah. But again, you have to understand there's an interaction going on. So if you did a DOE and you said, "Oh, well, they're all independent," then you could just say, "Oh, it's cool. We just need to monitor whatever is the, on the Pareto chart." But then that's one of the things that I see here, because in my mind, I'm like, do we, like, if we have historical data and we know when we've had problems, do we just run the data through there and trying different combinations? Like, do we just try to sort through? Because again, the computing power required for this, every PC has it, right? It's not crazy huge. I mean, even if it took, went nuts, it takes an hour to make a run. You just say, well, let's just take the hour. But and just run it through these T-squared studies. I've got 6 factors. I don't even know if any of them are important, but let me run through it and see if I see the pattern. I mean, I can see doing it that way, or as you said, do the as we talked about, doing the DOE. So I was just kind of wondering there. So but really, there has to be an interaction, or else I don't see any advantage.
Well, when you say interaction, in the example that we just saw, there's an interaction, right, between these two.
Yeah.
No, no, you got a question. That's a good question. How to choose the variables that are gonna play the game in T-square.
Yeah.
It's a perfect question. It's valid. No question about it. Yeah. Because you're not gonna be involved in analyze something that nothing has to do with the process, right?
Yeah.
So it's not going to affect, it's not going to do anything. Yeah, you're right.
Orfil, I have a comment. We work in automotive for a long time, and we work for a Japanese company. And the Japanese company didn't work by batches. They made it by one single flow. So we don't never use the T-square, because we don't need it. We just they found the first defect in part, and they just stop it and throw them away, and the next, if it's good, it's good. If it's bad, it's thrown away. So that's what the batches, and they are not used in that area.
Yeah, and yeah, that's a good question, Hector. The t-square can be run with individual values too. So you can run your
but it's not useful.
not batches, right? That individual values. And
yeah, but it's not useful because you decide right there without any chart. If it's good, it's good. If it's bad, it's bad. So
but the thing, Hector, is that whenever you say it's good or it's not good, it's because it's in compliance or not in compliance with the upper and control limit. But whenever you have dependence in those measurements, so it's not correct, that decision.
well, they are using different methodology. They are using the lean thinking methodology for the production. So they are using Kanban. They are using Pokeyoke, and they are using different methods
Okay.
for that. So the the t-square modeling, they are not using in the Japanese. The one, and it's the Yasaki, where I worked before.
Well, again, you know, the t-square is a sophisticated tool from the mathematical perspective. You saw the equations, so maybe because they want to use something more simple.
Definitely, yes. And I see the useful for t-square and companies that they make in batches, because they can trace it, but this is like an SPC, like you said.
Yeah, I think the application of t-square is not possible to introduce it in all the manufacturing processes, right? You're gonna find the right examples, okay?
That's correct. That's correct.
Where the application would be a benefit and really effective.
That's correct.
Not everywhere.
I agree.
Not everywhere.
I agree.
Yeah. That's why if I'm gonna go back to the chart. That's why I say that the core inspection tools, from my perspective, these days should be obviously acceptance sampling. You know, the old dinosaur should be is still there, right? Anom and QSAM is attribute 2, and these two processes are very effective for attributes because QSAM is stochastic. But whenever you have measurements, we talk about EPC, SPC last year. EWMA is another one that is very, very useful to detect small process changes. And with the same sample size, it's gonna detect the issues a lot quicker than SPC. So now T-square is a complement. So that's why, you know, I agree with you that it's not possible to implement it everywhere. You know, you are gonna have to identify the areas to implement it. Like I did in Medtronic, right? I introduced the T-square for the manufacturing of those medical devices, but not everywhere.
Thank you, Orfil.
Well, gentlemen, excellent questions. You have another question? I'll be glad to respond. You know, that's something that enrich the whole thing, the concept. You know, so this group is ASQ, right? Quality. And we're supposed to promote the best tools in quality. Okay, we as a ASQ, we should be the reference to many people. So whenever they want to decide what to do, they need to come to ASQ El Paso and ask. We can give a good advice.
All right, Orfil. Thank you, Orfil.
Yeah, thanks, Orfil, for introducing us to this. I think I like it. I like it. I mean, I think you're totally right. This is one of those things about the statistics element of quality with, more and more computing power. This is trivial
Yeah,
now. This is
yeah,
trivial. I mean,
yeah,
the judgment's not trivial, but the calculation effort is. It's just like you have to make sure we got the right data in here, but
right.
doing multivariate SPC, it makes a lot of sense.
Yeah. You know what happened in this equation, whenever you have two measurements with zero dependence, zero covariance, the acceptance is not an ellipse like this. It's a circle.
Yeah. Yeah.
Okay.
Right.
It's a circle. So that's why, depending on the level of dependency, the acceptance area is changing, is moving. So that's why the covariance matrix is very important to fine tune, day by day in order to make the best decisions.
Definitely.
Yeah. Well, we don't have the time. Otherwise, I should show you using Minitab how simple it is to run this data. It's absolutely simple, really. That'll take seconds in order to do it.
So we have time.
And identify the value of t-square and identify if you are in trouble or not. Really, obviously, it's not simple to identify which one was the responsible for the auto control, but that simple criteria can help us.
If anybody needs credit for recertification, please make sure that you send me your name, your ASU member number, and your email in the chat, and I will get that forwarded to our secretary for him to send out the certification letters.
Thank you, Jack.
Very good, Jack. Jack, you don't need another copy, right? I sent you the copy by email.
I have a
of the
copy, yes.
presentation.
I
Okay.
went through it when you went through it, and it was much
Okay.
easier to see on my 55-inch TV screen than my little.
Exactly. That's what I sent it to you because in other presentations I saw you that it was not simple for you to follow the whole thing.
Yes.
Thank you.
All right, guys. Next
Well,
month, Victor Assad is gonna present us, and I'm gonna be out in vacation with my wife and my kids. So
okay.
take care of him,
Have
please.
a good vacation.
Sure.
Thank you.
Absolutely, yeah. And when you said that, Hector, I thought this time was the one you're gonna be out, but I was confused.
No, the next month with Victor.
Okay. Yeah.
Victor as speaker. Yeah.
We'll take care of Victor very well. Don't worry about it.
Okay. Thank you, Orfil. Appreciate.
Thanks a lot, Orfil.
Thank
This was
you
good.
all.
Good night.
Thank you.
Good night.
Thank you.
Great.
Very
Great
interesting.
group. Thank
Thanks
you.
for stepping in.
Thank you.
Thank you.
All
Appreciate
right.
you.
Bye-bye.
Orfil,
Bye.
Orfil,
Yes,
do
Sergio.
you mind sending me your address via text, please?
My address? Yeah, sure. Yeah.
Thank you. Appreciate it, okay? Thanks
Not a
for
problem.
stepping in
And I'm glad you
helping us
made
out.
it.
Yeah, me too. Thanks for stepping in. Appreciate it, Orfil, okay?
Okay.
Thank you. Good presentation. We'll see you guys. Bye-bye.
Very good. Bye-bye, gentlemen and lady.
All right, Jack, you got the recording?
Yes.
All right. See you guys later.
Bye.